Hi, this is Mrs. Boykin talking about simplifying radical expressions. First, be sure that you reviewed the factoring videos, as you'll need to know how to factor in order to complete these problems successfully. Make sure that you know how to factor not only polynomials with 3 terms, but also when you have 2 terms, is it a difference of squares problem, or could it be a cubes problem, and that would be the sum or difference of cubes that would be factored. Remember, always look for the greatest common factor whenever you're factoring, and especially when you look at the numerator, and again, look for it again in your denominator before you begin your factoring process. Let's take a look at some examples. Of course, starting out real easy. We're looking at these 2 terms, and we can see they both have an x squared in common, so we can cancel those out. And 24 and 16 both can be divisible by 8. 24 divided by 8 leaves us 3. 16 divided by 8 is 2. And so therefore that would be our answer. Similarly, we have a problem here. Both 80 and 50 can both be divided by 10, leaving me with 8 and 5. And as far as our m's, I have m to the first power, m squared. Dividing both by m would get rid of the m on the top and reduce it to just plain old m on the bottom. And that would be simplified. But let's take a look at something a little more complicated. Remember the rule, we never want our polynomials to begin with a negative number, so we should always factor those out first. Dividing by a -1, we have n squared minus 11n plus 30. And nothing to factor out in the denominator. So factoring the numerator, we're going to have a negative, and then that's going to factor to n minus 6 and n minus 5. In the denominator, factoring that, and of course I'm not showing the factoring process because I've already factored my problems myself, but the key to this lesson is what we do after we factor. So we see in this problem we have a common binomial in both the numerator and denominator, and anything divided by itself is 1. So our answer is a negative n minus 6 all over n plus 7. Sometimes people might distribute the negative back in. I always leave it out. Also, I want to point out in this problem, we need to sometimes state the stated values that are would cause our expression to become undefined. I want to take a look back at these steps here. By factoring this denominator, we know that n cannot equal a -7 and n cannot equal 5. So those are our excluded values for this particular problem. I should have pointed those out first before I finish factoring or going on to simplifying. Let's take a look at another problem. And again, I'm going to factor this. In the numerator, I'm going to get n plus 10 times n plus 1. When I factored the denominator, I factored out a 3n before I factored the balance, and that gave me n plus 1 times n plus 1. Again, my purpose here is not to show you how to factor this again, but I divided everything by 3n. What remained, I factored to n plus 1 times n plus 1. So looking back as to what they share in common, I have an n plus 1 divided by an n plus 1. And, oh, of course, those excluded values. Let me talk about those before I get too far. The excluded values for this problem is your denominator. Your denominator cannot equal 0. So therefore, n cannot equal 0, because 3 times n would be 0, and 0 times anything would cause the whole denominator to be 0. N cannot also equal a -1. Again, because -1 plus 1 would be 0, and it doesn't matter what's here, anything times 0 is 0. So as far as simplifying the remaining problem, the answer would be n plus 10 all over 3n times n plus 1. And that would be it for this problem. Here we have another problem, and again, I can't stress enough the importance for looking for that greatest common factor. Initially, I was thinking I could divide everything by 9, and then I realized, wow, I can still keep dividing by yet another number. So after dividing by 9 and then by 3, I was like, I should have just divided the whole numerator by 27. Of course, I can factor out a k because all three of those had k terms. And that left me with k squared plus 3k plus 2 all over the denominator. I factored out a 9k from each of those terms and had 5k minus 3. I'm going to continue on to factor that numerator, but I'm going to stop here and we're going to talk about the excluded values. X cannot equal. If I set this equal to 0, k would be equal 0. Or I shouldn't say x, I should say k. Let me go ahead and erase that. I get so used to my variables being x's. So k cannot equal 0, and if I set 5k minus 3 equal to 0, and divide by 5, I can see that k cannot equal 0, nor can it equal 3/5. It would cause my denominator to equal 0, and therefore I would have an undefined fraction. So looking at what I can cancel here, I see I can cancel out my k's. 27 and 9 can both be divided by 9, leaving me 3 on the top and 1 on the bottom. Continuing to factor, so I now have 3 times, and when I factor this, I'm going to have k plus 1 times k plus 2 all over 5k minus 3. There's nothing else that can be factored out other than what I've done. This would be our solution with the excluded values listed below. One last problem and we'll call it a day. Looking at 27, 81, and 54. Let's see if I even figured this out on a sheet of paper before I worked it. I didn't, so we'll work it together. Okay, so what can we divide each of these by? Well, let's see. 9 times 6 is 54. That's the same problem. No wonder. Silly me. Okay, we've done all of our problems. I was about to do that one a second time. Anyway, so forget this one. We've completed all our problems. Again, don't forget that you could also have problems on your assignment that might be the sum of cubes, the difference of cubes, and if you remember, that's our SOFA's problem, or the sum or difference of squares. Again, watch those videos because all we're doing is factoring the numerator and the denominator using whatever factoring method is best, and then finding out what we can cancel from both the numerator and denominator that they share in common in order to simplify our rational expressions. This should say rational, not radical. Anyways, guys, hope you had a great snow day. Talk to you soon.